come from your visual mind. You have to be able to visualize what this looks like. So, as a quick example here, if we look at the board, I can take this, and if you follow my blue lines, I have across the bottom, and I have straight up and down. Okay? That gives me that right angle. Okay? A right angle measures how much? 90 degrees. Okay? So if you can, and I don't know if this will let me draw on it or not. So if you can visualize what that right angle looks like, minus my non-straight line, okay, it's going to start making sense to you when something is smaller or greater than 90 degrees, okay? And yes, it does matter because that's going to change the name. That's going to change how we identify those shapes, okay? So, let me erase this here. And let's look at it from a different standpoint. So, my question to you now, if I were to take this bottom bar and raise it to 20, and I take this, and I move it to 110. Is that a right angle?
Yes.
No.
Yes. Yes, it is.
How would I find out? Raise your hand if you can tell me how I would find out if this is a right angle. Okay? First of all, what I have to know about my protractor, when do I use my bottom numbers? When do I use my top row of numbers? Okay? Any time that my angle opens to the right, so it gives me that less than symbol, we're going to use that bottom row of numbers. Okay? If it opens this way, that's where we're going to use our top row of numbers. Okay? So, if we have an angle where it starts at 120, it starts at 20 and it ends at 110. My question that I pose to you is this a right angle? Yes. How do I know? Okay? So, raise your hand if you can explain to me very quickly how I know if this is a right angle or not and how I can check. Derek?
Subtract the number that your green dot is at, and by the number.
Okay, so Derek is telling me I'm going to take the larger number, 110, and I'm going to subtract the smallest number. Oops. If this is a right angle, what does that have to equal? 90 degrees. Okay? 11 minus 2 is? 9. So this is a right angle. Can I prove it to you?
Yeah.
Okay? What if I take, if I can get this
That would be
working, take my protractor. Oh, it's going to rotate the angle too. I thought I could.
That'd be 80.
Because if you think, no, 11 minus 2 is 9. If you think about this, all I did is raise this arm 20 degrees, so I expanded this arm 20 degrees. Okay? So, it doesn't just have to be straight up and down. It might be a sideways angle. Okay? But it still has the capabilities of being, at least, a right angle. Okay? So, even like this, we have to start being able to train our mind to visualize, Jeffrey, what this right angle looks like, no matter if I'm all the way over here at 130 and this is at, what would this arm have to be at for this to create a 90 degree angle here? If this one is at 130,
40.
look at my protractor.
40.
These two numbers, no, listen. These two numbers have to add to 180. Okay, so can we think about that at all to help us figure out very quickly what that needs to be at?
50. 40.
130 minus what gives me 90?
40. Wait, no.
So you're telling me here?
No.
Check it. Prove it. Is he right or wrong? Prove it on the board. Prove it on your board. Do the math. Okay? He's saying this one is at 130. Oops. Okay? So This one's at 130. He said this should be at 40. So I'm going to go up here and take 130 minus 40, and I better get what?
90.
Okay? So it does not have to be a standard where I have this angle down here at 0 and this one straight up at 90. Okay? You have to be able to visualize when those angles are turned. Once you can constantly visualize where that 90-degree angle is, it's going to be a lot easier for you to determine if something is acute, which is
Less than 90.
less than 90, or if something is obtuse, which is
Over 90.
okay.
But let's see one.
The other thing, if I have an angle that looks like that, that's a
Straight angle.
Straight angles measure.
120.
Okay? So, if my angle looks like this, am I measuring this way or am I measuring this way?
That way.
Okay? So, I'm going to measure this smaller portion right here. So, if we think about where this lays, okay, and we look at the numbers here, is this, okay, thinking about what 90 degrees looks like, is this open bigger than what a 90-degree angle is?
No.
So could it be 120?
No.
No, that automatically lets us know that it has to be a 60-degree angle. Okay? So as you're going back to remediate some of your papers today, think about that. Okay? I should never label something 120 degrees and tell you that it's acute. If I could spell today. Okay? So you have to be able to visualize what those angles are going to look like. The only way to do it is to practice. Okay? All right. I'm over that. And this afternoon, maybe we will, whenever I get back from my meeting, maybe we will take turns using this protractor to draw what certain angles will look like. But right now, I need that bad boy to delete. Okay? So, when I talk about an angle, okay? We'll say this is A, this is B, this is C. Okay? Does it matter if I call this triangle CB, or I'm sorry, angle CBA or ABC? Does that matter? No. Okay? The only thing that matters when you're labeling an angle is the vertex. Tell me which one of those is the vertex? B has to be in the middle. Okay? So I could say angle CBA, or I could say angle ABC. My vertex is in the center either way I list those. Okay? Questions about that? All right. Would this be obtuse, right, or acute? Obtuse. Okay? Quick brain buster for you. If this is obtuse, this angle will always be acute. Okay?
We knew that.
All right. If we have time later, we will practice drawing angles and measuring angles because I feel like that's probably where you need a little bit of assistance. Whenever we measure angles in this classroom, Cassius, I give leniency within 3 to 4 degrees, sometimes 5, but really I look for, if the angle measurement is 55, typically I will count anything from 53 to 57. Okay? You have to be that precise. Okay? If you noticed, whenever we pulled that protractor up, where did it throw that toolbar? My starting point is the center of my protractor right here. Okay? So I'm going to move that center point up to my vertex. Okay? So make sure you know how to use your protractor. Good on that?
Yep.
All right. On to today's lesson. If I could close out of the right things. Top of your page, you have the word polygon and regular polygon. Read the definition of a polygon for me very quickly, please. Ready? Okay, a closed plane figure made up of 9 segments. There are 2 key terms in there. It has to be closed. We'll cover that in a minute. And it has to have line segments. Does a circle have a line segment? No. Is a circle a polygon?
No.
Okay. Then we have the word regular polygon. Read that for me, please, Emma.
Regular polygon has sides of equal length and angles of equal measure.
Sides of equal length and angles of equal measure. Can you name one and tell your partner a polygon that's regular? I heard it over here. Square. Okay, a square. Okay, back to me. A square would be a very quick example of a regular polygon. All the sides are the same length. All the angles measure the same in a square. Okay? So we're going to learn different polygons today, and then we're going to learn how to tell if they're closed or open or irregular or regular. Okay? So let's get to it. All right, when we look at across the top of our book, we know that a figure that has 3 sides is always called a triangle. Okay, that should be one that you've known since you were very, very, very small. Okay? When we have the term quadrilateral, okay? Okay, we have this right here, quad. Quad means 4. Okay? We have a pentagon. Penta is a prefix that means 5. Gon comes from polygon, so a 5-sided polygon. So is it a closed figure? Yes. Okay? Then we have hexagon. Okay? Prefix means a hexagon is a 6-sided figure. Hexa means 6. Okay? Penta is 5. Quad means 4. Okay? Then we have an octagon.
8.
Octa means 8. Okay? You do, I will tell you 100%, you do have to know these shapes classified by their sides. You have to be able to count the sides of the shape, and you have to be able to know, okay, there's 6 sides, that means it's a hexagon. Okay, there's 8 sides, that means it's an octagon. Okay, there's 10 sides, that means it's a
Pentagon.
There's your brain buster. You have to come back to me tomorrow and tell me what a 10-sided figure is called.
Pentagon. My dad would know that.
Penta means 5.
What's your blue gun? It's a pentagon. I knew it.
That's your research for you. All right. Back to me very quickly. We're running out of time. A closed figure, very simply. Is this closed?
No. Art. We're learning art.
Okay. Is this closed?
Yes. Yes.
Okay. So it's a closed figure, but it's not a polygon. Okay. And then you have your terms regular polygon and irregular polygon. If all the sides are the same length, obviously it's